Welcome to lesson 4.3. In this lesson, we're going to use everything that we learned about inverse trig functions from 4.1 and 4.2 to start solving trig equations. So we're going to start with a pretty simple problem. We have a right triangle here and we want to solve for angle theta. So the first thing I would do is make sure to label your triangle so you know which SOHCAHTOA to use. We always have hypotenuse first, which is across from the right angle. Then we have opposite, which is across from the angle we're focusing on. And of course, adjacent is last. So if I look at this, I see that I am focusing on the adjacent side and the hypotenuse side. Those are the two sides that have things with them. Opposite doesn't have anything, so I don't really care about it. So if I care about adjacent and hypotenuse, that's SOHCAHTOA. So this is a cosine equation. So I get cosine of my angle, which I don't know, equals the adjacent side over the hypotenuse side. And now I want to solve this for theta. Now in the past, we've had a bunch of unit circle ones where we could just look up where this point was on the unit circle, find the radians for that point, and that was our answer. Now we don't have unit circle problems. So what we're going to do now is get rid of the cosine. Basically, we're focusing on getting the theta by itself, get the angle alone. Well, we learned that to get rid of cosine, we can do arc cosine because they're opposites. And then the arc cosine and the cosine will cancel each other out. However, if I do arc cosine to one side, I have to do arc cosine to the other side as well. So I end up with theta equals arc cosine of 9/12, which I can just put into my calculator. For now, let's make sure your calculator's in degree mode. In a little bit, we'll change to radian mode, but let's start in degree mode. So make sure your calculator's in degree mode, type this in, and you should get 41.41 degrees. So this is that. Then, if I wanted to solve for the angle across from it, I know that all angles in a triangle add up to 180. So I have 180 minus my right angle, minus the angle I just found, and that's going to give me 48.59 degrees. So that's solving for angles when it's not a unit circle problem, which is kind of what it's talking about down here. In section, oops, that shouldn't say 2.3, that should be 4.1 and 4.2. We learned how to solve problems like sine of theta equals 1/2 and tangent of t equals -1 because those are all unit circle points. So you go to the unit circle and say, well, where is the sine value 1/2? Where's the y value 1/2? Or where's the tangent value -1? And then we just listed all the angles that went with it. However, for the next little bit, we're going to do some problems that are not on the unit circle. These would be calculator problems. So let's start by looking at this first one. And once again, for now, make sure you're in degree mode. So what I want to do is solve for all the angles theta where sine of theta equals 1/3. And like I said, that is not on the unit circle. So this is not a unit circle problem, this is a calculator problem, which means I need to get theta by itself. I do that by doing arc sine, and I have to do it to both sides to keep it balanced. So those two signs cancel, and I end up with theta equals arc sine of 1/3. Which, once again, make sure you're in degree mode. We can just type into our calculator, and we get an angle of 19.471 degrees. Which, let's graph so we can see where this is. So it's a pretty small angle of 19.471 degrees. Now, also notice that this problem specifically says find all angles theta. So we learned that if we want to find all angles theta, we need to add 2 pi k. Or, since we're in degree mode, add 360 degrees K. And that will give us all our coterminal angles. So we have 19, and if I add 360, add 360, add 360, I keep getting back to that same point. Or you could also minus 360 and get the same thing. So adding that 360K or the 2 pi K if you're in radians guarantees us all angles. Now, here's the trickiest part. That's not actually all angles. And here's why. We learned from 4.1 and 4.2 that there are always two triangles. So if I look at this triangle here, this triangle has a y value over an r value of 1, 3. And I get that from this point, 1/3. Sine is y over r, so I get y over r. However, there is another triangle that has the same values, where the y value is 1 and the r value is 3. And that would be this triangle right here. Also has a y value of 1 and an r value of 3. They're symmetric and they have the same sine value. However, we just learned from 4.1 and 4.2, the reason our calculator gave us this one is because of the domain restriction. This is sine, which means it's quadrant 1 and negative quadrant 4. So our calculator did not give us that triangle, it gave us this one because it's the domain restriction that it's programmed to give you. So this is something that you have to think of when you use your calculator. The answer your calculator gives you is not the only answer. You need to draw it out and find the other triangle that has the same answer. So in this case, this triangle here has the exact same sine value. So let's find the angle of it. I know that this is going to be 19.471 because it's symmetric, but that's not really how we measure angles. I want this angle. Standard position, so from the positive x-axis to the line. So to find that angle, I'm going to do 180 degrees, the whole thing, minus the angle I found, that 19.471. And that should give me my blue angle of 160.528 degrees. And of course we still want all, so we add 360K to get all. So that's what we're looking at. Now, before we move on to the next problem, from here on out, I don't want you to use degrees anymore. I want you to use radians. So let's go through this exact same problem, but now put your calculator in radian mode. So we're going to start right here with arc sine of 1/3. Put this into your calculator when it's in radian mode. So once it's in radian mode, your calculator should now give you an answer of 0.3398. That is how many radians this much is. Oops, let me fix my marker real quick. There we go. So this is 0.3398 radians. And hopefully you'll remember from that, this is 0 radians. This is going to be pi halves radians, or if you put pi halves in your calculator, that's about 1. I always forget. Let me double check. 1.57. So if your calculator gives you any answer between 0 and 1.57 for radians, that's in your first quadrant. Over here is pi, or 3.14. So if your calculator gives you anything between 1.57 and 3.14, it's going to be in that quadrant. So that's another way to work on visualizing these radian angles. So I know this is 0.3398. However, I want all angles, so I'm going to add 2 pi k. And that gives me my first one. Then, once again, I need to draw it out and use that symmetry to know that this, let's go back to purple, will also be 0.3398 radians. But this time, instead of doing 180 minus, I'm going to do pi minus, because I'm now in radians. So if I do pi minus my 0.3398 angle, that should once again give me this blue angle that is the other triangle that also has the same value. So pi minus 0.3398 should give us 2.802 and add 2 pi k, so we get all. So the reason I had you do this problem in degrees first is because you're probably a little bit better at visualizing decimal degrees, where this decimal degree would go. But in 1060, we usually deal with radians rather than degrees. So I need you to get to the point where you're getting better at visualizing decimal radians. Ones that aren't in terms of pi, not pi thirds or pi sixths, but 0.3398 radians. So that is a really good example of being able to solve one of these problems using a calculator. Here's your degree mode answers. Here's your radian mode answers. For the rest of the problems on this page, which we'll do in the next video, I want you to stay in radian mode. So that's it for this video. Join me in the next video. We'll do some more examples in radian mode for solving these kinds of equations.